This is a motorcycle I designed based off of an old SV650, and in this video we're going to go over how I made the triple clamps. Okay, this is the stock top triple for the SV. We're going to put jigsaw forks on this, but we're going to start by reverse engineering these to get the geometry right. Main thing we're looking for is the stem and fork tube location, and then a couple other little things that we can pull into the next top triple. That print came out pretty good. Nothing too crazy here. So the next step is to recreate the jigsaw top triple. Same thing, we'll jump into CAD, trace it up, call out the key features, add in a little bit more changes, and then print a prototype to make sure that all of our geometry is accurate. So first print came out okay. A couple of things were a little bit off, a few millimeters out here or there. So went into CAD, made the changes, printed another, and then also added in some mounting locations for the handlebars and another one for the headlight and another one for the headlight, but now with a couple of other subtle changes and some updates onto the stem. And after that, we went back into CAD to finalize the model, threw it onto the 3D printer again. And then just for reference, because it's a simple part, it doesn't take much to set up on the slicer side, and print time could be better, but we'll take it. After we confirm CAD is good on this final iteration, we jump into CAM programming. We're going to be running 1-inch 6061 on my little hobby CNC machine, so it's going to be a tall order for this guy, but we're just going to try it and see how it goes. You can see here I'm confirming location on the part in relation to the material before we send it. So the real challenge in running this operation on this machine was keeping the chips and coolant out of the tool path so that the tool doesn't get gummed up and the surface finish doesn't get kind of crappy. I could have set up the material a bit better, meaning I could have removed all that excess and given the chips an opportunity to clear entirely out of the way, but really wasn't sure how I was going to do this, seeing as it was my first real run of a piece this big on this machine. So I'm happy with how it came out, but you can see I have to go in and use a paintbrush to clear the chips out while the machine is running. I'm also constantly tweaking the pressure on the mist, so a lot was learned here, and it did work, but I think there's just things that I could do better on the next one. After we pulled the part off the machine, chucked it into the mill, drilled out the clamp holes. I didn't show it here, but I also used a bandsaw to cut out that slot for the triple to clamp down onto the fork tube. And here we have it mounted onto the bike. So it worked. All in all, I'm happy with it. Learned a lot and look forward to making the next one. Speaking of, there are a few things I'll change in the future on the design side. Chamfers, a little bit of geometry, that sort of thing, but there are some obvious things that I could do on the machining side for the next iteration to make the whole operation easier, so I'll go over that now. What I'm going to do is make the rough stock much smaller and screw the stock that I'll be machining down to a fixture plate, and then that fixture plate will be fixed to the aluminum extrusion of the CNC bed. I think that will give me a bit more rigidity in the part, which should yield a better finish on the surface. And then also, because the stock is going to be much smaller, I think it'll allow for the chips to clearly evacuate from the tool path as the part gets machined. It should be pretty simple. I might even rough cut the stock to the silhouette of the part before I machine it, just so that there's even less material. The only thing next that I'll try and solve before I run it is some sort of evacuation for the chips in these pockets. I did notice that they filled up pretty quick, and I had to go in and hand vacuum out the chips while this part was running, but I'm confident I'll find a solution by the time I run this next iteration.